This video is over 4.1 Part 3 Slope-Intercept form. There's just one example from this part of your notes, and you are supposed to determine the slope and the y-intercept and then graph the equations using slope and y-intercept. So you looked up in your vocabulary at the beginning of this lesson slope-intercept form, which is y equals mx plus b, where the m is your slope and the b is your y-intercept. So in order to determine the slope and y-intercept, you have to have the equation solved for y, which as you can see on A and B, that's already the case. When an equation is already solved for y, you can simply look at the coefficient on x to determine the slope. In example A, we see that in front of x, we have a 1/2. That's going to be our slope. The constant, or the number without a variable, is your y-intercept. So in this case, -3. Once you know the slope and the y-intercept, you can use those two things to graph the line. The y-intercept serves as our starting point. That's the very first thing that I graph. So I'm going to put a point on the y-axis at -3. The slope, remember, is rise over run. Which tells you your vertical change over your horizontal change. So a slope of 1/2 means you're going to rise 1 and you're going to run 2 between any 2 points on the line. Since we have a starting point, we can use that slope to graph a second point. We go up 1 over 2 from the place where we started. I went up 1 and right 2 because I have a positive slope. We have to make sure from going left to right that our line is going uphill if our slope is positive. I like to plot as many points as I can on a graph. So from this new point, I would go up 1 over 2, up 1 over 2. In order to have a positive slope, you can also go down and left. So starting at my y-intercept, I'm going to do that. I'm going to go down 1, left 2. I'm going to keep doing that until I can't fit any more points on the page. Once you have as many points as you want or need, connect your points. You really only need 2 points to graph a line, but it's certainly easier to draw a straight line if you have more than 2. Take a look at example 2. If y equals 2x minus 3. First, let's identify our slope and y-intercept by looking at the equation, since it's already solved for y. Remember, our slope is the number that is the coefficient on x. In this case, the number 2 is what we're looking for. The y-intercept is your constant, so in this case, -3. We can go ahead and plot our y-intercept on -3, but our slope needs a little bit more work. Since our slope is not a fraction, we want to turn it into a fraction. Anytime you have an integer, you can put that integer over 1 to make it into a fraction. That means starting at -3, I'm going to go up 2, right 1. And I can continue to do that just like we did on the first example. I can also go down and left. Let's go ahead and make ourselves a note of that. Positive slope. I'm just going to use a positive sign. Positive slope. We can go up and right. Let's think about why that would be the case. Because if we go up, that's a positive direction. If we go right, that's a positive direction. And a positive divided by a positive is a positive. We can also go down and left. I encourage you to write this on your paper. Down is a negative direction and left is a negative direction. And a negative divided by a negative is a positive. Once you have your points, you can connect your points to make your line. Let's take a look at this last example. This one needs a little work. It's not solved for y yet, so we have to do that first. You need a little bit of room, so I encourage you to write it off to the side of your paper. We're trying to get y by itself, so let's start by moving that -15x. I always ask my kids to look what's farthest away from the y. So farthest away from the y is this. If it's negative, we're going to add it. We have to do that on both sides. So I have 5y equals 15x plus 10. Remember, we keep our x's and our constants separate because they're not like terms. Now I have to undo the 5 connected to the y. So I'm going to divide everything by 5. Once we simplify, we see that we have 3x plus 2. Now we can quickly identify our slope and our y-intercept by looking at our coefficient on x, which is 3, and our y-intercept, which is 2. And we're going to use the same technique that we used before. Plot your y-intercept at 2. Our slope is not a fraction, so we're going to put it over 1. We can go up 3, right 1 a couple of times, and then we can go down and left. Once you have your points, you can connect your points, and you're all done. As I finished up that last example, I noticed that we don't have an example with a negative slope. So let's talk about that really quick. If you have a negative slope, it's going to look a little different than what we've been practicing. Notice all of our positive slopes go uphill from left to right. A negative slope is going to go downhill. Let's look at the example y equals negative 1/2 x plus 2. If you have room on the bottom of your page, I encourage you to write this down. All right, draw a little graph. Our slope is negative 1/2, and our y-intercept is 2. So we start by plotting a point at 2 on the y-axis. Our slope is a negative 1/2. Now with a negative slope, I'm going to do the same thing I did above. You could go down and right. Down is a negative direction and right is a positive. A negative divided by a positive is negative. Or you could go up and left. Up is a positive direction, left is a negative direction, and a positive divided by a negative is a negative. So starting in our y-intercept of 2, we could go down 1, right 2. You could do that a couple of times. We could also go up and left 2. And notice when we get done, our line is going to go downhill from left to right.